So today I'm gonna focus just on the hands-on part of this. Again, if you're interested more in like how I use machine learning and applied linguistics, you can watch my recorded talk. I see some people coming in. Let me know if you don't have the Google Doc. I'll keep an eye on the question and Q&A panel and also the chat. If you already entered your information, go to this link on the top of the page, which is lael.ml.picoral.info. This is going to take you to our workshop instructions. So you see that the workshop starts like in one. We're going to start with preprocessed data. But before we do so, you have to make sure that you have R and RStudio installed. So I give a few minutes to install that if you don't have it. Since we're installing some packages today, like tidymodels, the package you're going to install is going to expect the latest version of R, 4-point-something. If you don't have an R version that is like 3-point-something, you probably want to install R again, update R, because the package is not going to like your R version. The other thing I want to say before you continue, let me show you how. Let me open. I have sort of R sessions open. Let me open a new one. Let's see. Session. Cannot see that. I'm going to show you in a moment. I'm opening my RStudio. So when I open RStudio, it tells me what R version I have. I do have the 4.0. If you want to find out, I forget system info, how to spell that. Let's see, sysinfo, I have it here on the session info. Is the command to get information about your installation. So let me know if you're ready in the chat. If you can say like yes or I'm ready in the chat box, that if you have it installed. Okay, I see some people saying yes. Okay, so today we're going to talk about, I'm saying yes, I'm ready, good. About how to build a classifier. So a classifier is like you give some kind of text. In this case, we're going to work with tweets. So we're going to give, appreciate the link. Yes, I'll give you the link. Sorry, I'll give you the link to the doc. And in that document, it has the link to these instructions that I can also post to the chat. So today we're going to, like I was saying, we're going to work with classification. So we're going to build a classifier, and my plan is to have 2 types of models, one for with logistic regression, another one with random forest, just to give an idea of different things you can do in tidymodels. And we're going to work with data from Kaggle. If you don't know Kaggle, I highly recommend you create a user ID. So this link is on the instructions page in 1.1. There is a Kaggle link there. So we're going to work with Hillary Clinton and Donald Trump tweets from the 2016 election. We're not going to work with the Twitter API in R, although it's pretty easy to use, but we're going to work with the data that is returned by the Twitter API. So if you go to this Kaggle page, you go download, we're going to download this these tweets. I'm downloading it, I believe. Did I was distracted? Yes. Someone said I can't see the instructions page. I don't know what you mean by that. You can't access this link. The 𝗂𝗂𝗍𝗂 page is in the instructions. So if you scroll down before we start, which is the instruction for R, it's how to install R in RStudio. In 1 and 1.1, you have the link to 𝗂𝗂𝗍𝗂. All right. So I downloaded the data. Let me show you. So we downloaded it with the file is going to look something like this. I'm going to unzip it. Let me find it where it went. All right, when you unzip it, you get something like this, tweets.csv. If you can't access 𝗂𝗂𝗍𝗂, let me know. I'll find a different way to send you the data. But again, the instruction pages, there is a 𝗂𝗂𝗍𝗂 link here. And then that's going to open the 𝗂𝗂𝗍𝗂 page. You have to sign in. And then just click download, unzip the file. Let me put this somewhere else so you can download in case you don't have access to. So Larissa Gloria, you can try the link that Larissa sent you. I can also try to. Put this somewhere so you can access. I'm showing where to get the data because my hope is that you can do other projects, and 𝗂𝗂𝗍𝗂 has a lot of data that you can play with. Okay, I also put it on my Google Drive, the zip file. Okay. I'm gonna get rid of the zip file because I don't need it. I'm gonna put it in the trash. And then I will show you how to, we're gonna do a R project. It's not, it may look an Excel file, but if you click on it and open it, it's gonna open with Excel, but it's a comma-separated file. It has to be tweets.csv. And it must look like this. I'm opening it, take longer. It's a text file that is comma separated. All right. So if you open your Excel, it's gonna look like this. But if you open on a text editor, let me do this. It's a comma separated file. That's where the CSV comes from, comma separated value. So you're gonna see that all the data, of course, it's very hard to read, but you're gonna see that each column name is separated by a comma, and then each value is separated by a comma. This is a very common file format that we use to, it's easier to transmit data. I'm gonna create a folder. I'm gonna say LAEL Machine Learning Webinar Workshop. And then inside this folder, I'm gonna create a data folder. And please do the same because I'm gonna assume you have this structure. I like to organize all my projects like this so that it's easier for you to open the project and know what's going on. So inside this data, I'm gonna move my tweets.csv. So please let me know if you're having any difficulty downloading the file. And if you have the file downloaded, please do what I did, create like a work. It can be named, the project folder can be named anything, but inside, please use, add a folder called data, and then it's still downloading, okay. And then add the tweets, the data tweets.csv to your folder. When people say still downloading, they're downloading R in RStudio, or they're downloading the data? RStudio, all right. Let me look at the newer version of RStudio. We have a lot of, so if you're done downloading and you're done downloading data, you can look at the document and maybe add some other information there while we wait a little bit for everyone to be ready. I see a lot of people in applied linguistics and linguistics, comparative linguistics. Nice, from different countries as well. Yeah, so I see that some people work with different languages. So today we're going to work just with the lexical items. We're not going to work with any kind of tagger or anything, because my goal is to show you how to build the classifier. Of course, in addition to just the words or the lexical items, you can have other information, right? And I know that Larissa is giving a workshop next week to show you how to tag your files with your text files with the Stanford Dependency Parser. I'm gonna open my RStudio. It should look something like this. And then before we start again, we're going to install some packages. I have all of these. You could have this in all one command, but you should install each one of them. And if you already have, it's gonna update. So there's no harm in trying to installing a package again. So my tidyverse needed update. So the reason why I wanted to install each package separately is so you can see if there are any errors. So when you open your R, like I said, you'll see this console. You should see this console. And then you see this blue greater than sign. It's where you enter your command. Put it here. I don't know, put it what here? Someone said on the chat, put it here. I don't know what it refers to. So all the commands I'm gonna use, you have in this website, right? So just open this website. A lot of people are adding the, yeah, so then you can follow along. Tidymodels. So tidyverse is a package that I use a lot. I'm not a base R user, although I do some stuff with base R. But tidyverse has like dplyr. It actually says here when I load the library. It has a bunch of libraries that I use a lot. Tidymodels is the library we're going to use to train our machine learning models. This one is going to take a while to install. R sometimes asks me this, do you want to restart R prior to installing? I say no. And if it asks you, do you want to compile packages from a source? I also say no. Oh, I have a lot of stuff that, oh, it's trying. Okay. It's downloading. They update these packages quite often. It's always good to keep stuff updated. All right. So now text recipes. So tidymodels has a package called recipe inside of together bundled with the model, with the package tidymodels. But there is a recipe package specifically for text. Recipes is a package. We're going to see how, that you create a recipe and then you bake your data or you juice your data to create your data set. So we need to transform the data into lexical items. That's what we have. We're going to see that's what we have for tweets, into numbers. And there are different ways. You can do like frequency of words for each tweet. You can do something that's called term frequency, inverted document frequency, which takes into account range and so on. So recipe is a package that makes that process really easy and clean. Skimmer is a package that I use for data summarization. I just like to use it. And then we have two packages for the two types of machine learning models we are running today, which is the generalized linear models, which you're going to run logistic regression with, and the random forest package. And we're going to visualize the results of these two models to kind of give you an idea of what they do. Okay, I have all my packages installed. Let me know if you're still installing things, if you have any errors, or if we can move to data analysis or a little bit of data analysis. I'll wait for you to catch up. It's a lot of packages to install. Awesome. And I know that some people may have computers and internet that are faster than others, so this may take a while longer for some people. While some people are finishing installing, I'm going to show you, when everyone is done, I'm going to show you how to create an R project. The reason I always create R projects, because it makes it much easier for you to, yes, I see other people using R projects. It makes things more organized. You just open your project and you have all your data, like you have a data folder, you know where your data files are, and you know where what scripts go with those data files. And I can also share my code with other people. I can move my folder around and they're still gonna work. If you have the famous set working directory, if you used R on the top of your file, or if you do that, it's much harder for you to keep track of things. You should never use that. Projects make things much better and easier to find. So once you have everything ready, we're going to create a project. So remember, let me remind you that I have on my desktop, I have a folder called LAEL workshop, LAEL workshop. And inside that folder, I have a data folder with the data we downloaded. So we're going to make this folder into an R project. Let me find my R studio again. All right, so the way we do that, you on your R studio, you go File, and New Project. And then because we already have the folder or you know, the directory we want to use, we're going to choose Existing Directory. And then you're going to browse. You're going to find that directory. Mine, remember, is LAEL workshop. I'm going to click Open and Create Project. Yes, so we're going to create a project with the existing folder. So go File, New Project. And then a pop-up window is going to open. You choose existing directory because we already have a folder where we want to create a project. Then it's going to tell you, where is this folder? Clicking Browse. And I already have but then choose the folder you want. Mine is LAEL Workshop on my desktop. Click on Open. And then Create Project. I'm going to create again. And then what's going to happen, you're going to see that in your folder that you created with that data folder, there will be, yes, this video is being recorded. So it's going to be available on the website. Every time you want to open this project, just click on this R project, this .rproj file, and then it opens for you, and then you don't have to worry about setting your working directory. If you have it working the first time, it increases your chances of working in the future. So that's the problem. Sometimes you go back to a project 5 years ago that you started 5 years ago and nothing works. So projects help you with that. Okay, so now that we have our project, you're going to see here on this bottom right panel, the same thing you see in your, if you go to your Finder or your on Windows, it's File Explorer, right? So you see your project folders here, which is very handy as well. So we're going to link to the Google Doc again. Yes. So we're going to start by creating our R script. So you can click on this little button here, New File, which is like a little white rectangle with a plus, green plus. We're going to start with the R script. And I'm going to save this because I always save everything. And I'm going to call this something that I'll remember later. So Clinton Trump tweet ML. You can call it whatever you want. It doesn't matter. I like to call it something that I can search later and I see what it is and I can find it. Okay, so I'm going to save it. And you see that my file shows up both in my folder here and also in my window. Let me know, I can make this big too, because I know, let me make this a little bigger. I have to remember what's the, oh, found it. All right, I'll make this bigger so you can see. Okay, so remember that we saw all those packages. Now we're going to start using them. So the first library, what step, sorry. The last step, I just created a new file and a new R script. And then I just saved it with whatever name you want. How to get to this screen? To the, so you have your console, right? Have your R console? Okay, and then you just, you have an icon on the top. You can also go File, New File. And then we want a new R script. Or you can click on this icon and say R script. And then you save it with whatever name you want, it doesn't matter. I'm gonna just resave it. What did I do? Okay, I'm just gonna open the one I had saved before. Right, so now you should see your R script. We're going to work with the script. You still have your console on the bottom. There's where you're gonna load things. So an R script is like a document. You saved it and then you work on it and you run things, and then you can rerun things at any time you want to keep things organized. So we're going to load tidyverse. So you see that I started typing library, and it's gonna give me some autocomplete options. I can hit, in my keyboard, I can hit tab to autocomplete. And then I'm gonna load the tidyverse. Again, I start typing, and it shows me all the packages I already have installed. If tidyverse doesn't show up here, that means you haven't installed it successfully. So to run, so this is just a document, right? I didn't run anything. To run something in from your script to your console, that's where things run. You can click on this button, run. You can also go anywhere in the line and hit, hold on a Mac is a command, hold the command, and in the on a Windows is control. So you just do, I hold command and then I press enter, and it also runs. And you can do this at any time, any point in the line. You don't need to select everything. You can select everything, but no need for that. So you see that the first time you run the library, is gonna tell you all these different packages that it's attaching. So tidyverse is like a universe, has a bunch of packages. Let me know if you're good. If you're good, if you were able to run library tidyverse and you see something similar to me, say yes, I'm good on the chat so I can have some idea of how things are going. You also see that I have this green line. It's a comment line. So commenting, okay, when you say please could you repeat, I don't know what you're talking about. So repeat what? In R, you do not have to run the whole file. You can press run after highlighting the line. Sure, but this is not running the whole file. This is running just one line. Highlight, I can show you highlight later. You can't see the Facebook link now. It's not gonna let you rewind. When it's live, you just can watch at the same time. What warning messages? Do you have any warning messages? Warning messages are usually fine. If it's a warning message that you have an older version of R, you may have that. It may cause problems when you are going to install tidymodels. So warning messages are you say, oh, this package was created for a different version of R. Okay, so let's talk about comments. So I always comment my file. So you can create a comment by doing a hashtag or a pound sign, whatever you call it. And then this line is gonna be a comment. That means it's not gonna be run. Yeah, so the warning is that you have a different version of, it may be okay, the warning may be fine, but you may, again, if you get any errors in the future, especially with tidymodels does require the newest version of R. If you say I couldn't install, permission denied. Okay, so you've got an error. just copy that error. I don't have any helpers in this workshop, but copy that error and put it on Google. Google is going to tell you. Usually when you get errors, when you load packages or install packages, again, it's because you don't have the newest version of R. So you have to make sure you have the newest version of R in RStudio. And on Windows, you have also to ensure that you have the right version of R installed. So there is the 32-bit and the 64-bit. You have to check which version of Windows you're running to install the right R when you download it. All right, so I'm gonna say load data. Oh, and before we continue, let me just show you something. So we're going to do 3 processes here. We're going to pre-process data, train models, and inspect and evaluate models. So we're going to, so all of these are pre-processed data. So I'm going to say pre-processed data. So you see that if this is my title, if I add 1, 2, 3, 4 hashtags after the title, it creates a section on your RStudio. So I do this to, again, keep things organized. Okay, so this is process of data. And then we're going to load the data. So first, check if your data file is where you think it is, right? So it's always good practice to see like, oh, I have this data file inside my data folder, right? So to check that, I'll use the command dir, and I'm gonna say where my data is, which is the data folder. You don't need this. So this is just like, I expect my data, my tweets.csv to be inside my data folder. So I'll run this. And again, you can run this holding command or control for Windows. I think it's control for Windows. Hold the key and then enter. You can also run this by clicking on this run button and it runs the current line. So I see that my tweets.csv is inside that folder. So, okay, I'm reading so if it's a warning for RTools, you can ignore it, it's fine. RTools is just to build packages. We're not building any packages. So you can move on. So you're good, Beth. So again, so if you run this command dir and data between quotes, you have to see in your console that tweets.csv. So now you know that, okay, it is here. I can see it, right? So we can actually load our data. So I'm gonna call my data. Let's see what I'm following the instructions I sent you earlier. So I'm gonna call my data tweets. This is the name I'm giving. It can be anything. It can be A, right? We don't want it to be A. So I'm gonna be tweets, and then I'm gonna use because my data is a CSV file, that's comma separated file, I'm gonna use the command read _ not period _ CSV. Oops. And then inside a string, I'm gonna say my data is inside data folder, and it's called tweets.csv. So again, this command, if you want to copy and paste, is in the instructions. I can link this again, and it's under 1.1, import data. Okay, I'm gonna run this. I got some messages, which is fine. It's just telling me which columns there were in my data. There was an ID, there is retweet, and so on. And here in my global environment on the top right, you see a new object. this is a data frame. So this is the tweets. Let me know if you can't do that, or if everything looks good, just say good or yes or ready. Great. There are different ways of inspecting your data. You can do head, which is what we have in the instructions. So head is going to give you the first few few like lines, which is hard to see. I like to use view, and it has to be view with a capital letter. So this is going to open the data frame in a different tab on the top. So we see that we have an ID. It seems that the ID is for the user because we have Hillary Clinton. I can click on a column, like on the header, to sort by the column. Oh, it is different. Okay. So it seems to be an ID for the user. We're going to ignore that. The text is the one we're going to work with. And then there is all, like when you use the Twitter API, which downloads some tweets for you in R or in other, like Python, other programming language, you're going to get a bunch of other information. We're not going to worry about these because today we're going just to focus on the handle, or if it's like, you know, Hillary Clinton or Donald Trump, and the text. Before we move on, I also want to show you the library 𝗬𝗵𝗲. I like 𝗬𝗵𝗲, and this is the only thing we're going to use today with 𝗬𝗵𝗲, but I wanted to show you. So load the library 𝗬𝗬𝗲, and then you can skim your data. Instead of doing summary, you can do skim. So skim also just gives you some information. Sorry, my screen is big. So it tells you how many columns, how many rows, how many variables of each type. So there is 17 categorical, 7 numeric, and so on. It also gives you the number of missing. So we are interested in the handle and text, and there are no missing data for these two, which is good. Let me tell you also how to see who is tweeting. To see who is tweeting, we can get tweets. Let me make a comment. Just to see if we have two labels, right? So we can get our data, tweets. And then, so we're going to use the pipe. There is a shortcut for the pipe. I wrote here, I never use it, but I wrote maybe I didn't write. It's command, if anyone knows by heart what's the shortcut for this, it's command, no, that is M. Okay, found it. It's command shift M or control. So you can do control, hold control, code shift, and code M, the letter M, or if you're on a Mac, hold command, control shift. So this is a pipe. It just means then, right? Yes. So you get the tweets, and then you're going to count the handle. So this is going to give you a count of how many observations there are per handle, right? So you can run this, and you see that we have only two handles. That's good. That's what we want. We have almost the same amount of tweets for each one of these people. We can also see when they are tweeting. So remember that I mentioned when we were looking at the Kaggle page, this is from the 2016 election. So there is a column that says time, we could do time. Yes, time is the one. So we want to see what's the minimum and the maximum are for this time here. so we know that when this were tweeted. So we're going to do min for minimum value. We're going to get our data frame, tweets, and we use $ to indicate, look at this column. We want to look at time, and we want to get the minimum of this time. So it looks like the first tweet was tweeted out for this data set that we have here, 2016, January 5. And then let's see when was the last tweet that we have here. Same thing, we're going to do tweets time, but we're going to get the maximum value. So the last tweet we have on our data set is September 28th, 2016. It's not timer, it's time. So if I do this timer, it's going to say unknown variable column. I don't know if that's the error you got. So that means that it hasn't found the data. So what's the error? Like whenever you say I got an error, please paste the error to the chat so I can kind of try to diagnose what the error is. Is that all? Error in summary factor? I'll copy and paste, try to paste what I wrote. I mean, copy and paste what I have on the. Oh, so your error is in the count. Could not find tweets. So do you see tweets in your global environment here? If you don't see, that means you didn't run or you got an error in this line. Could not find function tweets. Yeah. So, or yeah, try that. If you see the. And everything else ran. Sorry, I won't have a lot of time to diagnose errors. So I'll keep moving on. Sorry. So you have to make sure that, again, you have, when you read the file, you have to say read _CSV. If you do read.csv, it's not going to work because this is a different way of reading file. I'm using the tidyverse way. Yeah, so read CSV is not going to read anything as factors because they're against that. Anyways, maybe the way you read your data, if you maybe didn't use the, yeah, so. Okay, so let's move on. Like I mentioned, we want to clean this. We don't want everything. We're not going to worry. We could use in our machine learning model the different variables. We're just going to use the handle, which is going to be our label. And my classifier is basically going to say, is this tweet by Donald Trump or by Hillary Clinton? And my assumption here is that just by looking at lexical items, the words, that Trump and Hillary Clinton, they're going to use different words. And that's going to be able to make the machine learning model identify who the author is, right? So let's select what we need. So I do clean tweets. This is the name of my variable. And I'm going to just get my original tweets. And I'm going to use a pipe. And I'm going to select the handle and the text. That's what it's called, right? So I just want these two columns, handle and text. And then I'm going to get this result. If I just run this, this is where you can use select. I can select just this part, and it's going to run just the selection. You're going to see that it shows me a table with only 2 columns. Right, so I'm going to save these results in clean tweets is not on my global environment, but I'm going to run the code as is without selecting it. And then now you should be able to see clean tweets on your global environment on the top right panel. It has the same number of observations or the same number of rows, but only 2 variables. So if I look at it, I see that I have just the 2 columns. And now we're ready to start our transformation. So I'm going to create a division here. I'm going to name it sample and transform. We need to transform our data because the machine learning algorithm is not going to understand this. We need a vector of numbers. So we're going to transform all of these words into counts, right, for each word. we're going to see how it looks. Okay, so transform and sample data. For that, we need our tidymodels library. I'm going to run it. It may take a while to load this. It's going to tell you attaching packages and any conflicts. If you get an error here, it may be that you don't have the right R version installed. So basically, the package installed is expecting a different R installation than you have. And then you have to make sure that you have the latest R installation. All right. Let me know if the library loaded, at least for some people, by saying yes, ready on the chat. Can wait a few minutes. Yes, it loaded. Okay. We're going to set a seed. I think you saw that in previous workshops. Oops, where am I typing? Okay, sorry, I first changed windows. Set seed. So we're going to do some randomization here. We're going to basically split our data into 2. We're going to get 80% of the data for our training. So where we're going to build our model with this 80% of randomly selected tweets. And then we're going to evaluate how accurate our model performs on a test data, which is 20% of the data. Usually, you want 3 data sets. You want one for development and another one for testing. But I may have talked about that in my webinar if you want to watch that. So set seed, the purpose is so that when you randomly select 80% of your tweets for your training, every time you run this, you're going to get the same 80%, the same tweets. So it makes your project more reproducible, so you get the same results every time. In your set seed, you can choose any number. It can be 1, 2, 3. You know, it can be your favorite number. My favorite number is 42. It can be any number. It only sets the seed. That means that whatever number you chooses is gonna, when you choose that number over and over again, you're gonna get the same random selection of tweets. I ran that, so it's over here. Sometimes I forget to run commands. I type on the top and I don't run the command. Okay, so we're going to randomly divide our data into 2 data sets. So 80% of our tweets are going to be for training, and 20% of our tweets are going to be for testing. And this is standard practice, okay? Sometimes people do 75%, 25. So this division can be different depending on the size of your data set. All right. So we're going to create a data split variable, which is going to hold what we want to do with the data. We want to use a function from our sample, which is a package inside tidymodels. And this our sample in 2 columns just say, get a function from this package. Because sometimes packages have the same functions, and we want to make sure that it's getting the function from the exact same package. And then we're going to do an initial split, which is going to set up our data split. So our data that we're using comes from clean tweets, right? So this is, remember, the data that we have that has only the two columns I'm interested in, the label and the text. And then the proportion I want, a prop is going to be 80%. So if you want to look at this function, you can do the help in the console. You do question mark initial split. And then it's going to tell you, you're going to see that the default proportion is 75. We want 80. We want a little bit more training data. You can also do stratification sampling. We don't need that because our observations are pretty equal, so we're fine. So keep in mind that this initial split, splitting your data, you can do it in different ways. What we're changing here is just that instead of 75% for training data, we're doing 80% and 20. So I'm going to run this. And now I do have a data split in my global environment. And if I just run this, again, I can select this and run to just see data split. Or if you want to, you can just have a new line. Data split is going to tell you the same thing. Okay, so what this tells you is that for my data split, I have a total of 6,400 tweets, which is all my total observations. And then my data is going to split training. I have like 5,100 tweets for my training data and 1,200, around 1,200 tweets for my test data. So this just tells you it's ready to go. I have this set up already. But now I actually have to divide my data because I haven't done that yet. I just have this data split set up. For that, so I'm going to create a comment here, create each data set using this data split. So we're going to create a train data for my training data. So here is actually when I'm going to use this data split to actually randomly sample my data, which is defined here for 80% of all tweets. So I'm going to use the function training. And I'm going to use where this split is coming from, which is this data split. Right? This is my variable. So I have my training data, and I'm going to put that in train data. And I have my test data, which I'm going to use the testing function this time. Testing the same variable data split. So this is going to put 20% of all tweets in the test data. So let me run these two. So now I do have my test data and my train data on my global environment on the top right. And you see that originally we said that there will be 51, 56 rows for training data. And that's how many observations I have here on my global environment. And we have 1,288 observations for the test data. If we view these now, train data, it's going to look exactly like the clean tweets. The only difference that these were randomly, 80% of all tweets randomly selected. Okay, so now I have our two data sets. I think this is a good point to take a 5-minute break. And I'll try in this 5 minutes, you can use the restroom. So we start again at 11 in the next step. And I can answer some of the questions. So what's the shortcut for run? For Windows, you hold Control and then press Enter. For a Windows, you hold Command and press Enter. Let me know if you have any problems, and I'll try to answer in the next 5 minutes before we continue, and before maybe people are taking a bathroom break. Or if you want me to repeat anything, let me know in the chat box. You don't have R. So did you, so let's see, who said that? The R. I don't have the R sample tool. Rafael, are you sure? So our sample comes from tidymodels. Did you get any errors when you ran library tidymodels? Because our sample is a library. There should be. Okay, Joseph Casillas. The random sample of all tweets, it's going to be, yes, exactly. So it's going to divide equally, right? Not equally, 80%. So it doesn't sample randomly again. It does divide, it splits the data. So it randomizes the data first, and then 80% of all tweets go to training data, and the rest go to testing data. So it is, the testing data is training data. It's just that it does two steps at the same time. It randomizes and it splits the data. How would you define both training and testing functions? I don't know if I understand that question. Julia, this training and testing functions are from our sample, and they just implement whatever you defined in your data split. I don't know if that's an answer, though. If you want more information about each one of these functions, you can do question mark, and then the name of the function, and then enter in your console. And then in the help, which is the left bottom right. Sorry, I have a problem with left and right. Right bottom panel, this bottom over here, has information about this training. Actually, I think it came the same is initial split, because this training is used with initial split. Yeah, so it's like all in the same page. So they're used together. I don't know if I answered your question. But anyways, let me know if that was not a good answer. Okay, so I do have some question and answers. Do we need to add packages every time we need to use? So the packages, so installation, you just need to install, in theory, you just need to install it once. You should make sure your packages are up to date. So the analogy that people often use is that, let me go up here. So we see that I didn't even wrote the installation code in my script, because you don't need, so all of these, you can run it only once. This is like when you install a package, you kind of put it, that package in your computer, and then that's a book, right? So you just buy the book once. And then every time you want to use it, you do have to run the command library. So library is when you want to use it. You go to your library, say, retrieve this package. So whenever you want to use the package, you do have to run library. But installing, you just do it once. I don't know even if the person's here, but I answered this question. So is R the same as using Twitter API? No. So Twitter API, you can use the Twitter API in R, and the package is that I use is rtweet. So this is a different package, rtweet, and then this allows you to retrieve tweets, right? Which is not the topic of today's talk, but basically when you use this package in R, you can create this data set we're using. So this step was done for us. We're not going to do it, but you can definitely replicate whatever we're doing here with your own set of tweets, and then you can search tweets instead of like tweets by Trump and Hillary Clinton. You can search tweets that mention immigrant or some keyword or by some person. So that's what the Twitter API can be used for. So no more questions. Let's move on. So now we're going to, let me see where I stopped. So we have our train and our test data. So now we need to transform our data. So we need to get this text or these words. We need to tokenize them, split them. And at first we're going to just count. So I want to see, I'm going to create, no, it's not a matrix because matrix is a different thing. But it's a data frame where each column is going to be my term. In this case, it's going to be a word. And then I'm going to have for each tweet a count how many of that specific term there are in each tweet. Okay, so now is where the fun starts. Well, let's, sorry, I'm kind of obsessed with this. I'll do sample data here. And then this is transform data. People who work with me, I know there are some people here, they know how annoying I can be about these things. But now look, I can go to like sample data, pre-processed data, transform data. That makes me happy. Anyways, I don't need to say yes all in capital letters, Larissa. Right? It's like, no, you're not annoying. You're just like things the right way. Anyways, library. We're going to use this fun library, which is text recipes, which are recipes for text data. Again, type library and the name of the library you want to do to load, and then load. Mine didn't give me any errors, so we're all good. So then I'm gonna create, this is where the magic in my mind begins, because I've done this process of preparing the data in both Python with scikit-learn and in R, and this makes this so much easier. So my recipe, I could write my recipe, but let's keep, that's what I wrote in the instructions. So I'm gonna say my recipe. So I'm gonna use the recipe function, which is the recipes package. And the text recipes add some other functions to this. And then I'm gonna say that I'm gonna give both my dependent variable or my predictor by what I want to use to predict my data, right? So remember that we have only two variables here. We have the handle, which is our label, which is what we want to classify. So basically what's gonna happen that in our classifier for each tweet we give it to the classifier is gonna tell me if it thinks it's authored by Hillary Clinton or Donald Trump. So that's what we're trying to train, right? So we want to predict the handle. So that's our predictor by, so you use the tilde, the squiggly line, which varies where it is in your computer, but you can copy from the instructions if you can find it, by the text, right? That's what we want to. And if you've done any regression or any modeling, this is very standard syntax. And then we say, we give our data. So remember that our data here, we're going to not give the train and test data at first. I'm thinking now. No, my data should be, sorry, I made a mistake in the, it should be train data. I made a mistake in the instructions. So we just want to use the train data here, I'm pretty sure. So use train data and not clean data because we want just the 80%. And then, because otherwise, if you use the whole data, then there is no point in having test data. Anyways, so this is our recipe. Get the train data. And then from this, you have two variables. The handle is going to be predictor, and the text is going to be what I'm going to use to predict the author of each tweet. And then all the other steps, they can vary. But you do need usually for text data, because it's all one word, one string, sorry. We want to tokenize. So you have a step tokenize. And we're going to tokenize their text. So this step is going to get our tweets and split into individual words. And then we want to step token filter. So we want to filter these tokens that we have. So it's the same variable text by minimum times. And I'm gonna show you that you can do this in different ways, but for this, I'm gonna say, get only the words that occur at least 50 times. So this guarantees that I don't have one instance, because of course that instance is gonna happen just one tweet. It's not gonna be helpful. If you look at the step tokenizer function, which I did with !step tokenizer, you can also get the top. So I did like minimum times. You can do maximum times. I don't know why you do that. I don't know. You can get maximum tokens, but you can also get you can do a percentage. Anyways, there are different ways of doing this, right? What I'm defining here is just saying, get only the tokens or the words that happen at least 50 times in the whole corpus. This is a pipe, someone asked. You read and then. So what we're doing is like, we're getting a recipe and then we tokenize the text and then we filter, we just keep all the tokens that happen at least 50 times in my train data. And then, so the pipe, I'm going to, my next step is to get the term frequency. Now that I have my tokens and I have only the tokens that occur at least 50 times, I'm gonna calculate term frequency for these. So that means just count the frequency of each word from the ones that were left that occur at least 50 times, and count per tweet, And that's it for now. Oops. And then the last step is always prep. You prep with the data. I'm still thinking about this train data because sometimes you can put the train data here. That's what I'm thinking. Anyways, let's see what happens. Otherwise, I'll just change. I think I did make a mistake in the instructions. Okay, so this is my recipe. Just like we did with the data split, the recipe doesn't do anything. It just gets everything ready. So I'm going to run this. And then I can look at my recipe, and it's just going to give information about the recipe, right? It's going to do tokenization for text in the train data. I do think it does only for train data. Text filtering for text. So I may change this to the original clean tweets. Anyways, well, let's see. And then term frequency for, so these are my 3 steps, right? Tokenize gets the minimum of 50, and then get the term frequency. I have just one outcome on one variable, right? It's handle, which is a binary variable. And I have one predictor to begin with, which is text. And training data has my 5156, which is correct. Got an error. Okay, what's the error? Specify at least one variable specification. Do you have, okay, does it say which? Nothing will come out. Nothing will happen. So if it does this, nothing's gonna happen. So that's normal, but it should be, my rec should show up in the global environment. This error, Tony, is that it's usually when you don't have text in the middle, you don't have an argument inside of one of the steps. So make sure you have that. Location 50 can subset the columns that don't exist. So, sorry, again, I don't think I'll have time to, thank you, Larissa, I was gonna do that. I don't have time to go over your errors. Just make sure that, Larissa posted what you have to type. If you still get errors, make sure that you ran everything. Sometimes you have to run from the beginning. So it may be that you missed running a line, and that's why you're getting the error. All right, so I have my recipe. So yeah, when you run this, you're not gonna get anything because it just created this my recipe. if you look at it, that's what you get. You can see information. Okay, so now we're going to actually transform our data sets. So for that, so now we have the recipe, and again, we can transform using the recipe. So I'm going to do prepped train data. So I'm going to get my train data, and I'm going to add a prep to this variable. And this, I'm going to juice, that's the function. You're going to get my recipe and juice it. I do think, let's see what happens. Oops. Let me just check something here. For prep. Well, anyways, I'm still thinking if I did this right, but let's see. And then I'm going to prep my test data. And instead of juicing, I'm going to bake. I know these are weird, but it's just because it goes with the recipe, I think. And then I'm going to do the same recipe, but I'm going to use the test data instead. Right? So for the prep data, I'm going to juice, which is going to use this recipe. And then for my prep data, I'm going to bake because I'm giving a new data set. So I'm going to run both my lines. And then if I look at them now, the prepped one, so that's the transformation, right? So remember that at first I had the handle and the whole text. So the transformation was to get the handle, and for each token, this is a, about, again, all Americans, amp, right? So this is ampersand. So for each one of my terms, for each one of my words here that occur at least 50 times, I'm going to get a frequency for each tweet. So that's what we need to run the machine learning model. And this, if you were in the previous, was the topic, modeling, this is basically also you can use for other things, right? You can even do multi-dimensional analysis, factor analysis, right? Because now we have frequency, not norm frequency, you can do norm frequency, but basically creates this for you with just these steps, which to me is magic. All right, so now that we have our data, we can finally train the models. Let's start with logistic regression. So again, you see that there is a pattern here. You first prepare what you want to do. Oh, does the zero, Beth asked, does the 0 and 1 mean for each column? Yeah, so the 0 here, what it means here is that for this tweet, the first one in this data, there is no a, there is no about, there is no again. So it's a count, right? So this is a spare data set frame, right? It's going to be a lot of zeros because I do have, how many columns? Let's see, prepped. So there's 101 variables. So I'm not going to have all 100 words in just one tweet, right? So this third tweet has one a, one about. So it gets to, in the 7th tweet has two a's. So it just is the count, right? And because there is 100 columns, there will be a lot of zeros. I don't know if I answered your question. Okay, so following the pattern, we're just going to define the model first. So I'm going to call this my GMNet model. And it's going to be a logistic regression. And okay, I'll put some hyperparameters here, mixture and penalty. Hyperparameters are anything that the machine learning engineer defines. This can be tuned automatically. We're not going to go into that today. But basically, you have to adjust these parameters to optimize your model. If you want to read more about that, my instructions in my page in the bottom has some other resources for tuning. We're not going to worry about the hyperparameters today. We're just going to set the simplest engine we can think of and go with it. So this is my engine. This is my first setup for my logistic regression model. I'm going to run this. Nothing's going to happen because I just created this as a setup. And then we're going to train model. This is going to take a while. So I'm going to do my 𝗬𝗵𝗵 model. And then I'm going to use this model I created previously, which is called this. I'm going to just copy and paste so I don't make mistakes. And then we're going to fit our data to this model. Remember that our predictor, our label is handle. So in my prep data, it's still handle. It's called handle. It's a binary variable. And then I have 100 other columns. I'm not gonna type all of them here because there's no reason for me to do that. I could start by TF tax A, but that's a lot of work. Just do a dot to mean everything. So you don't have to type all 100. And then my data is my prepped train data. So let's see if this works. Again, it's going to take a while. Ah, was actually quite fast. Let me know if you ran this and basically nothing something happens, but you shouldn't get any errors. If you're good, can you say good? Yes, ready, something on the chat so I can say I ran it. Okay. Is it taking a while? All right. Awesome. Okay, before we evaluate this model, let's see how much time I have. I do have 40 minutes. Let's train the random forest model. So random forests is a different algorithm. It does something else, right? The dot here means everything, right? Because I have 100 columns. So remember that before we did a handle by text for the original data, because in the original data, we just had a text one column, right? For the prep data, we have 100 columns. So for me not to type all of the 100 columns, because I want everything anyways, I just use the dot. So the dot is a shortcut that means all of the variables. That's what the dot means. All right. Random forest. So random forest model. So it's the same principle. I'm going to create this setup before I train or I fit my model, right? So in this case, I want the random forest variable. Another hyperparameter, we're just going to say, give me 100 trees. You do have to say mode for this because, oops, sorry. In the 𝗬𝗵𝗵, it is a classification default. So here we're going to say it is classification that we want. It's not regression, right? It's a binary variable. I just need to classify if it's Trump or Hillary. And then again, I'm gonna define my engine. Oops, this is typing, it's hard. Set engine. And between quote marks, I'm gonna do random forest. So this is where I'm getting my engine from. There is a lot of different engines you can use. I'm using two. There are R packages, like we saw in the beginning. We installed both the 𝗬𝗵𝗵 package and the random forest packages. There are other packages you can use, even like 𝗬𝗵𝗄, that you have to install in Python and so on. So run this. Nothing should happen. You just see the model in your global environment, and then we train the model. I'm going to say this is my random forest model. I don't know why I chose such difficult names for it. And then I'm gonna, so I just added my in the, I don't know if this is a great practice, but I'm gonna get this model and I'm gonna fit. Again, same thing. I give my predictor, which is handle by everything, all the other columns, dot, and my data is, sorry, my window is kind of small, huh? Exactly the same thing as before. So it's my prepped train data. Then I run. Nothing should happen. This does take a little longer. Elisa, be careful with your capitalization. F, yes. F has to be capital, yes. R is case sensitive, so you have to type it exactly how it is there. I didn't explain, 𝗧𝗪, I didn't explain what random forest does. I mean, these are two, again, the purpose here is just to show you how to do this. Logistic regression is one form of like classifying. This is a binary classification. And random forest is another way, is another algorithm. My goal here is not to go over the algorithm with you. My goal is to show you though the output. So you basically create like, it's gonna create 100 decision trees, if you know what decision trees are. And it does use regression as well. Everything is regression. No, sorry, yeah, I didn't explain, sorry, I didn't explain what random forest actually is. So far, what you need to know is just one way to train a machine learning model. All right, so now let's, do we want to evaluate or inspect? Let's inspect our models first. So now I have two models, two trained models. We're going to look into them. These two models, you can look into them and see some of the coefficients and the decisions. Some other machine learning models, they are kind of a black box. You can't really make sense. Even random forests, I don't know if you can make sense of what the decision trees are. But we'll look at it. So maybe you understand a little better what they do. So we're going to use one of my favorite libraries, 𝗏. 𝗏, you can use, like, if you fit any kind of model, you do tidy, and then it transforms the summary of that model into a data frame you can work with. So just do library 𝗏 to load this. And then we're going to start with the logistic regression model. Sorry, my brain was blanking there. So I have this trained model, right? So I want to look at this model. So I'm going to look at this model. So I'm going to start with this. And I'm going to get, oh, if you look at this, you're just going to see a bunch of stuff, right? And actually has a number of variables inside. So we're going to do $. We want to look at the fit. So if you look at this again, you're going to see a bunch of stuff. So I want to use the tidy function, which this tidy function is from 𝗏. It makes things a little better, much better. So it tidy things up for you. So you're going to see that there are steps here for the machine learning, because that's what logistic regression does. Let's view this, it's easier. So the intercept is just, it's the bias term. It tells you if there are no words, what is the probability of predicting a label. And in this case, I forgot to mention, So Donald Trump and Hillary Clinton. So, well, no, a real Trump, right? Real Trump. So Hillary H comes before T for Trump. So because alphabetically Hillary Clinton handle comes first, that's going to be 0 or 0 in my logistic regression. And real Donald Trump is going to be 1. So basically that makes all of our probabilities in relation to Trump's tweet. Is this basically our question by default is this strip written by, this tweet written by Trump? Just because it's alphabetical order. So that's what the intercept tells you. It gives you the probability in log odds of a tweet being guessed that is Trump, which is close to 0 because the number of tweets we have for Trump and Hillary is basically the same. So logistic regression runs in a number of steps. You see the last step is 100. So we're going to filter our data to get just the last step. And also we want to get rid of the intercept that we saw here, because the intercept just tells you, doesn't tell you anything about the actual words. So we're also gonna filter for term different than and it has to be exactly what is written there, which is intercept with capital I between parentheses. So we're getting rid of the intercept. What else do you want to do? Oh, I also want to, do you see that each term starts with TF text? This tells me this came from the text column on my tweets, and it's a term frequency. I want to remove that so I have just the word, so it's a little cleaner. So I'm gonna do a mutate, and then I'm gonna mutate the term variable so that it doesn't have that TF text. So I'm gonna do a 𝗔𝗵𝗃, which replaces something. So I want to replace the beginning of each one of these, which is TF text, with nothing. So basically I want to delete that from term. Okay, so I'm just cleaning up a little bit. What did I do? Okay, instead of using the, okay, I just had this imported. Let me view. So now I have only step 5 and I have the term is clean. It looks better, but I'm gonna put those results in my coefficients. I'm gonna remove the view. This is the final. I'm gonna paste here to everyone. So this is, I went step by step just to show you what they were, but this is the final text to get just the coefficients I want. So the coefficients, so basically what the logistic regression does, it runs many, many times with different, for each word, because again, in this case, my predictors are my individual tokens. It adjusts the probability of that word being in a tweet by Trump or by Hillary Clinton. So basically I have for each word, I have a coefficient that tells me is this word going to help me? Is it going to increase the chances of this tweet being by Trump or by Hillary Clinton? I'm just going to copy and I'm going to go over the code to view this. So this is just to plot. I'm getting this table, this coefficient table, and plotting it. I'm going to paste this in the chat. I don't have time to go over each one of these, but basically what it tells you is, all right, so these are the top 20 words for each prediction. So remember the positive is predicting Trump. So the token that is most predictable, that the most helps, like that helps the most to predict that this tweet was written by Trump is the word crooked, which makes sense, right? So what's basically telling us, like, a crooked is a word that happens a lot in Trump tweets and not in Hillary Clinton tweets. So if that word is present in a tweet, this is going to increase the chance of the model predicting that this was written by Donald Trump. Trump 2016, make America great again, Cruz from that Cruz. What is interesting, so you, in the recipes, you could remove stop words. I didn't remove stop words on purpose because I want to see pronouns. It does seem that I and me are pronouns that are more common in Trump tweets because they help predict that this tweet was written by Trump. While in Hillary Clinton, so here are the highest coefficients that predict, for tokens that predict, that help predict that this tweet was written by Hillary. So she talked about families, she does talk about donut, she talked about Americans, your, us, and we. To me, this will be like, if I were to do like some kind of research of this, I think it's interesting that Hillary Clinton used us and we in her tweets because they help predict that the tweet was written by Hillary Clinton, while for Donald Trump, he uses I and me, right? You can exclude, yes, you can exclude the hashtags. You can certainly do that. So yeah, so this is the point, like this is actually, this 𝗕𝗿𝗀 is a link. You could exclude that. So this is the point where you look at your features and see if you want to exclude anything. Maybe there are some things that are garbage. Maybe you don't want to include any links, for example. We're not gonna go over feature engineering. So every time you do a machine learning model, there are two things you do to optimize your model. You do feature engineering and also hyperparameter tuning. All right, so this is how you look into the machine learning, the logistic regression. You can look at the coefficients for each token. And then if they're positive, they're gonna help predict that token helps predict that that each tweet, which is our unit of analysis, is written by the reference. So if you got my coefficients not found, make sure that you ran this, because that means you don't have that object. All right, so let's also look at, you're gonna evaluate the model. So let's see how accurate it is. We didn't do a lot of tuning, so I don't know. I'm not gonna, let's see. So I'm gonna get my model again. Before I was visualizing, right? I was looking at my model and doing the coefficients, but now I'm gonna use it to predict new data. So whenever you have a model, you can predict any tweet, right? You give it a tweet, and then it's going to tell you whether it thinks it's written by Donald Trump or by Hillary Clinton in 2016, right? As they were in 2016. So we're going to use the function predict. Our new data for this case that we're going to predict is our prepped test data. So it's the test data we've already prepared. And we are going to define the truth. So our gold standards, because we have those labels, right? We know who wrote this. That's how we can assess our models, because we have the handle for this. So this is where, what is our gold standard? This is where we know, from our data who wrote it. And then we're going to calculate accuracy with the truth. So we created this variable truth, which is basically the labels from our data, from our test data. And all right, let me run the first lines. So these two first lines is just gonna tell you the prediction, right? This is what the first tweet I think is Hillary Clinton. The second tweet I think is Hillary Clinton. So it creates this prediction class, which we're using here. So basically we're doing the prediction and we're matching the prediction against the truth. And the truth comes from our original data. So let's run this. Oh, accuracy of 82. That's pretty good. So there are really words that help us define, because it's not, if I were to guess, it would probably be 50-50, right? But the actual words are helping us guess with 82% accuracy if the tweet was written by Donald Trump or Hillary Clinton. In addition to accuracy, you can run other things. Other measures. I'm not gonna go into what the difference between precision, and accuracy. So precision is a little lower. So this is all from all the tweets that were predicted to be written by Donald Trump. How many were actually written by Donald Trump? So that's what prediction tells you. Oops. And then you can also do recall. So recall is also called as sensitivity. So recall is a little higher. So recall tells you from all the tweets written by Donald Trump, how many were I able to identify? You can read more about the difference between accuracy, precision, and recall. It's good practice to report precision and recall, especially when you have more than 2 labels with a multi-class model. All right. Now, let's do the same for the random forest models. You can read more. Oh yeah, let me do this because I like doing that. So in addition to, sorry, we have 20 minutes. I'm kind of running through this, but in addition to predicting the label, which is the default, you can also change the type of this to probability. So what did I do wrong? Why this didn't work? Anyways, so if you change the type to probability, the default is the label. Then for each tweet, they're going to give you a probability of being written by Hillary Clinton versus Donald Trump. And with this, you can calculate certainty. If your prep data is not, test data is not available, probably you didn't run the lines before. So if it tells you it cannot find a variable, it's just because you have to go back and make sure that you run that line that created that variable. And with this, so anyways, you can look at individual tweets and see why some tweets are, more easy to predict than others. All right, so let's move on to inspecting the, my thing does that sometimes, it gets stuck. Okay, inspecting the random forest model. So again, let me just remind you that my random forest model is this variable here when we trained. So it's my random forest model. So for this model, we're going to do the same thing. We can do the prediction like we did before. So remember that for accuracy, we have predict the new data, the prep test data, get the truth from the handle, and then get me the accuracy, compare the truth with the actual prediction. We're going to do the same thing. So I'm just going to copy and paste here. Oh, let me run it. So remember that the accuracy for the linear regression, logistic regression, was 82%. For the random forest, so I'm just changing the model. It's a little higher, it's 85%. So you can do exactly the same thing with the random forest. In addition, so random forest will give you 100 trees, decision trees. So random forest is the package. Random forest is the package, and we can get a tree from this. So we're going to look at the model fit. there are 100 trees. So I will look at the last tree. There is no reason to do that. I'm looking at the last 100. And let's get the variable through. So if I run this, I'm gonna look into my random forest fit. I'm gonna look at the last decision tree. And then it's gonna give me this weird thing. So it's a tree, right? So it's gonna give you the nodes. Let me get just the first 10 nodes, because there are so many nodes. There are like 2,000 nodes, I think. Yes, there are like 2,000 nodes. It's a huge tree. It's impossible for us to look at all of that. Let me look at the first 10. So I'm gonna do head 10 here. This will give you the first 10, which is not very helpful unless you can tree. So it gives you each node. It tells you which nodes are the next and what the node is, which doesn't make much sense, right? I'm gonna show you what a tree looks like. I'm trying to find the code. For this, I did use someone else's code that is linked in the. So someone did the same thing as I did here. I got the tree and I have the link in the instructions. It gets the tree and it actually plots. So there is a plot here. I'm just gonna run their code. I usually save my functions at utils. You don't have to, you're not gonna do this. I just wanna show you what the tree looks like. If you are interested, what did I do? The code is linked in the instructions. Let's see, this works. Okay, all right, there it is. So where's my tree plotting? Sorry, I have to find the function. What is the name of the function again? And I just created tree function. Okay, so this is the function I have to run. Again, you're not gonna run this. I'm just going to show you that it's possible to see this. I'm not gonna over the code, but I want to go with the final model, which is this. Let's get the tree number and let's get the first 20 nodes. Let's see if this works. All right. So I just wanted to show you what a tree would look like. Oh, it's messy. So basically what a decision tree, and they're in the random forest model, there are like 100 of them. This is like frequency. So basically if it says yes or no. So if there is a word, the word thank in the tweet, if yes, then you go right. If it's no, you go left. So if there is the word thank, then look at word so. If there is the word so, then look at the word I. If there is the word I. So basically this is what a tree looks like. For each node, it has a threshold. This is the count. Remember that that's what we're using. And it gives you a visualization of whether, you know, by each word, if it's present, if it's, you're not gonna have half a word, right? You're either gonna have 0 words, 1, 2, 3, right, is an integer. So this is what the beginning of this decision tree looks like. I just wanted to show you, if you want to look at the code, it's linked into the instructions. Okay, so I think that's what I had it for today. I kind of ran through the rest. You do have all the instructions into my link thing. The only thing I wanted to show is that now you can change. Oh, you do have one more thing to show you, and then if you have any questions, you can ask me. Is that if I go up to my recipe, and I do have suggestions in this instructions, I have suggestions on how to change the recipe. So remember that we use term frequency. Instead of using just a count, we can use this other step, which is term frequency inverted document frequency. So this takes into consideration the range or how many tweets this happens. So now that you have the recipe, it's really easy to change. I can go to my recipe. So instead of using step term frequency, I can do step term frequency inverted document frequency, which is a normalized frequency kinda. And then I run this again. And then now my recipe is gonna tell me, oh, you tokenize, you filter your tokens. And then instead of calculating just term frequency, I'm calculating term frequency inverse document frequency. So now when I prepped my data, I will look at it with view. So again, before we had just a frequency, right? 1, 2, or 0. Now it's a normalized frequency by how many documents it happens. So it's a different type of feature engineering, right? So now I can run everything as it is again. We can do this, we can do this. So I just changed one little thing in my recipe. And I'm not gonna train the, and then it changes, because again, I didn't have to run the library, because now it's considering range as well. I don't know what I did here, it looks weird. Oh, here it is. Right, so this is not considering just count. Cricket is still on the top, right? It's very similar, actually. We may have some differences. But anyways, now that you have the whole code, you can change the recipe and just run everything as is. How can you learn? So Beth asking, I'm looking at the questions. How can you learn about the different usages of each code? It seems that each code may have more than one purpose. So maybe you're asking about how to, like I mentioned, there are like a lot of things that you can tune in your model. So it depends on your purpose, right? Here we're using precision and recall to see how good the classifier is. So our question is, can we actually see differences? Can this classifier actually make it, like using the words in the tweet, classify, like see differences between a tweet written by Hillary Clinton versus Donald Trump? It does seem that the words do help, right? Because it's like 80% accuracy. So if you want to improve your model, there are different feature engineering you can do to make your model perform better, right? And also maybe your feature engineering includes things that you are not interested in, right? In my webinar, I talked about, so instead of having tweets by 2 different people, I had texts written in Portuguese by 2 different types of learners. So I had multiple texts written in Portuguese, written by speakers of Spanish versus speakers of English. My label here was like, my classification was, is this text written by an English speaker in Portuguese, was written in Portuguese by an English speaker, or by a Spanish speaker? And then I saw that one of the most, the labels or the tokens, the words that most predicted whether it was an English speaker or a Spanish speaker that wrote this text, is the word inglés, which means English in Portuguese. So this is more like topic related, right? Which is not interesting to me. So it depends on the model and what you use. It depends on what your purpose is and what your research question is. Yes, so what would the research for this project, like for the tweet project, Danley? I don't know what this project means. For the tweet, it's like what can you actually, so my research question is like, do the words that these people are using, are they characteristic of, can they define the author, right? Do people actually have their own vocabulary that they like to use? It does seem that that's the case, that there are certain words that Trump uses more than Hillary Clinton. So this is looking just at lexical items. If you had the text tagged for part of speech or dependencies, which is a syntactical relationship, then you could say like not only the question, and I think you can watch 𝗏𝗂𝗍𝗏 𝗥𝗲𝗂𝗀𝗏 webinar, which is also recorded. He does talk about more of the research question, in the sense like how do we use lexical items, vocabulary, or lexicogrammatical features to identify the author, right? Do people actually have different ways of expressing or writing tweets in this case? That's like, in general, what the research question would be. We do have 9 minutes. Oh, I have another question. About phonological phenomena. Yes, you could use this, but again, your tweets would have to be, not tweets, right? But if you have oral text, it depends on how you transcribe it. So if you do have it annotated by whatever, I don't know what phonological phenomena you're interested in, this is a question. But of course, you could have tokens, right? It's like, oh, this, whatever your unit of analysis is, if it's just a video, like say you're looking at YouTube videos. And if you want to annotate or transcribe your audio with using some kind of annotation that tells you about phonological phenomena, yes, you could use phonetic transcription, for example, for sure. So it's just a matter of having it in text format, right? You need to have it in a way that you can count it somehow. And transcribing it is much harder than just getting tweets, which are already written. Can I talk about my data file organization? I'm not sure what you mean by that. My projects, maybe. I always have a data folder where my data goes. I always create a project. And then for my reporting, you create, if you go to File, R Markdown, right? You can create an HTML, which I use to create the instructions, or a PDF. I don't know why anyone would use a Word, but you can use Word. And then now that will be another workshop. But then once you have your data analysis, and usually how I organize it, here's my original. I do have different files, and I think 𝗏𝗂𝗀𝗃 talked about organizing your data in different files. I do have all my scripts in different, like 01, data wrangling, 02, pre-processing, 03, modeling. I find this easier to edit. So I don't know if that's the question, but that's, again, would be a whole nother workshop. I do have recommendations. I have a list of resources here. I put 3 links: a gentle introduction to tidymodels, and the text recipes, and some tools for tuning if you want to. This is what I recommend, especially the first link to start with. What I don't understand the question, what is 01 versus 02? Oh, in my organization, it's just the order. So this means run 01 first, just for me, right? I know what the order is. I know that I have to run 01 before 02, before 03, and so on. And I think we're out of time. You can email me. My email is, did I put it somewhere here? In this instruction? No, I didn't. I failed to do that. Let me do it in this document. My email is adrianaps@arizona.edu. I'm also on Twitter at Adriana Picoral. I do a lot of these workshops, and I'll be doing more. So you can follow me on Twitter or just email me if you have any questions.